स्टूडेंट्स 2 मिनट वेट करते हैं और ठीक है फिर शुरू करते हैं। ओके, गुड आफ्टरनून एवरीवन। Okay, students, so we will start. So today we have to discuss, okay, about the last topic of this unit, and this is superconductors. And in superconductors, what we have to discuss? We have to discuss type 1 and type 2 superconductors and their applications. Okay. भाई मेरी आवाज आ रही है सभी लोगों को? स्लाइड दिख रहा है?
Yes, sir. Good.
Okay. Let's move to superconductors. Okay. So superconductors. You know, metals, they are conducting in nature, means they can conduct electricity. Okay. So in addition to their ability to conduct electricity, they often have electrical resistance, means they have opposing power. Okay, or they have feature to oppose the electrical conductivity, means they have some kind of a resistance in between them. Okay. I think all of you know metals, they are a good conductor of electricity. Okay, but side by side, depending upon the nature of metal, they have some kind of a electrical resistance, means they will resist to the flow of electric current. And this is the feature of metals. Okay, or metals which have less electrical resistance, you can say that they are a good conductor of electric current. Okay, so whatever the metal, okay, whatever the metal we have, they always have more or less, okay, electrical resistance. Some metals maybe they have high electrical resistance, or some metals maybe they have low electrical resistance. Okay. But in case of superconductors means they have superior electrical conductivity as compared to simple metals, normal metals. Okay. Superconductors, they do not have any kind of electrical resistance. This means they do not oppose to the flow of electric current. Okay. So this is the feature of superconductors. This is the property of superconductors. That's why we are calling them superconductors, like supercomputers. Okay. So superconductors, they do not have any kind of electrical resistance. Okay. And this concept of superconductivity or superconductors, okay, it was you can say discovered by a Dutch scientist in 1911 by a Dutch scientist Kamerlin Ons at the University of Leiden in Holland. He discovered this concept. Actually, he observed that. What he observed? He observed that when we cool the mercury, you know, mercury, it's a metal. Okay. When we cool the mercury, or he accidentally cooled the mercury by using liquid helium up to 4.2 Kelvin. So he found that upon cooling the mercury up to 4.2 Kelvin, that mercury at this temperature, it shows high electrical conductivity with zero electrical resistance. Okay. अब उसने क्या किया भाई, उसने एक मर्करी सैंपल लिया नॉर्मल रूम टेम्परेचर पे, उसका उसने इलेक्ट्रिकल कनेक्टिविटी देखा फर्स्ट केस में, और दूसरा क्या किया, उसने अपना मर्करी लिया, उसको उसने कूल किया अप टू 4.2 केल्विन पे. ओके. फिर उसका उसने इलेक्ट्रिकल कनेक्टिविटी पावर चेक किया, एंड ही फाउंड दैट आफ्टर कूलिंग द मर्करी it has high electrical conductivity with zero electrical resistance. Okay, so this scientist Kamerlin Ons, he named this process, he named this mechanism, this phenomena as superconductivity. Okay. आपके पास दो कंडीशन है. पहले क्या है आपका RT मीन्स रूम टेम्परेचर, सपोज 26 डिग्री सेल्सियस. 26 डिग्री सेल्सियस पे you have some electrical connectivity. Side by side, the mercury metal, it has some electrical resistance, and after cooling to 4.2 Kelvin, the mercury, it has zero electrical resistance, no oppose. Okay. And under this situation, it has the mercury, it has high electrical conductivity. So this phenomena, it is named by this scientist as superconductivity. Okay. And at the temperature below which an element exhibit this kind of feature, it is known as, it was named as a critical temperature. It is known as or it was named as a critical temperature. अब यहाँ पे हमने डिस्कस किया कि मरकरी को जब आप कूल करते हो 4.2 डिग्री सेल्सियस, सॉरी 4.2 केल्विन पे, ठीक है, उस पे जाके क्या हो जाता है, इट विल बिकम सुपर कंडक्टर. So 4.2 Kelvin, it is the critical temperature here. Okay. Below this temperature, your mercury, it is superconductor. Okay. So critical temperature, it is written denoted here by letter Tc. Okay. See this graph here. On the x-axis here, you have temperature. On the y-axis here, you have resistivity, electrical resistivity on the y-axis. So in the beginning, when the temperature is high, okay, you have two cases here. Normal metal, how it behave when you decrease the temperature. This, remember, superconductivity, it is the feature of some metals. Not all the metals, they exhibit this kind of feature. Okay, some metals they exhibit, some metals they don't. So in case of normal metal, when you decrease the temperature here, okay, so what happened? Their electrical resistance, it decreased little bit and it become constant here. Okay, अब यहाँ पे आप देखोगे, so you will have some value of electrical resistance here for the normal metal. This happen in case of normal metal when you decrease the temperature. Now see the metal which can behave like a superconductor. Okay, in that case, what happened? If you see here, in that case, if you see, when you decrease the temperature, their resistance also decrease little bit here. At particular temperature, you will see there will be sharp decrease. ठीक है, यहाँ पे क्या हुआ? Initially, यहाँ पे initially in the beginning, you have decrease, okay, in the resistance, slow decrease in the resistance, and at particular temperature here, you will see here a sharp decrease in the sharp decrease in the resistance, and it becomes zero here. If you see this point here, you have zero resistance, okay, at this temperature. Okay, so एक particular temperature पे आके जो आपकी electrical resistance है वो finish हो गया, ठीक है, खत्म हो गया, बिल्कुल zero हो गया. Okay, so this temperature here, it is the critical temperature. This temperature here, it is your critical temperature. Okay, so this happen in case of superconductors. Okay. Superconductors, when you cool them and at particular temperature, that is the critical temperature of that metal, they will show superconductivity. This is a feature of a superconductor. Okay, just wait a minute. Just wait. Okay, so this is the feature of superconductors. Okay, भाई समझ में आया सभी को कि superconductors के केस में क्या होता है? भाई समझ में आया सभी को? अभी लंच वगैरह तो नहीं कर रहे हो सभी लोग?
सर आ गया समझ.
अच्छा, ओके, तो मुझे बता दिया करो भाई सारे लोग, ठीक है, कोई बीच में बोल दिया करो. Okay, now there are some features of superconductors that now we are going to discuss that one. So superconductors और when any material, देखिए इसका मतलब हमने जो लास्ट स्लाइड में डिस्कस किया ना, इसका मतलब क्या है कि नॉर्मल सिचुएशन में, नॉर्मल कंडीशन में द मेटल it behave like normal metal. Okay, it is not acting like superconductor in the normal situation at normal room temperature. We need to provide some particular temperature, okay, under which the metal, it will behave like a superconductor. Okay, so we can call that the metal it is in its superconducting state. Okay, so हमारे हाथ में है, we can control the behavior of the metal. We can make the metal as a superconductor or as a normal metal. Okay, it is in our hand. Okay, so when you have a metal present in the superconducting state, when you have metal present in the superconducting state, it is diamagnetic in nature. It is diamagnetic in nature. Okay, remember this is crucial point. Okay, when any metal it is present in its superconducting state, it is diamagnetic in nature. It is diamagnetic in nature. And just wait 1 minute. Okay, so I was saying that whenever any metal it is present in its superconducting state, it is diamagnetic in nature. This means it is repelled by the magnetic field, or it is repelled by the magnet. Okay, this is the feature of a superconducting state. Okay. Moreover, if suppose see this figure A here. Suppose you have a metal in its superconducting state. So when I am saying a metal it is present in superconducting state, this means that the metal it is present below okay, the metal it is present below its critical temperature. ठीक है, अगर metal critical temperature के नीचे होगा, it will be present in its superconducting state. ठीक है, अगर metal उसके critical temperature के ऊपर present होगा, ठीक है, then it is not behaving like superconductor. ठीक है, so this you have to remember. So suppose you have a superconducting material, आपके पास superconducting metal है, but it is present above its critical temperature. ठीक है, आपके पास कोई metal है, ठीक है, ये superconductor तभी बनेगा जब इसको आप जो आपका TC है, critical solution, critical temperature है, उससे नीचे आप metal को रखोगे. Under this condition, this metal it will behave like superconductor. ठीक है, and if this metal it is present above the critical temperature, okay, and after that if you place this metal in magnetic field, okay, in that case what happen, the magnetic force lines, the magnetic field you can say, it will penetrate the metal, it will pass the metal. Okay, see this figure A, you will have this situation here. As you can see in figure A, the arrows it denotes here the magnetic force, the magnetic lines, magnetic field, and the circle in the center it is your metal which is present above the critical temperature. Above the critical temperature, here the metal it is present here. Okay, so this is the first case. This is the feature of a superconducting materials. सुपर कनेक्टिंग मटेरियल सुपर कनेक्टर तभी बनेंगे जब उनको आप क्रिटिकल टेम्परेचर के नीचे रखोगे। ठीक है, अगर क्रिटिकल टेम्परेचर नहीं है तो वो सुपर कनेक्टिंग स्टेट में नहीं होंगे। इट इज जस्ट ए सुपर कनेक्टिंग मटेरियल। ठीक है, तो उस केस को डिस्कस कर रहे हैं हम। आपके पास यू हैव अ सुपर कनेक्टिंग मटेरियल व्हिच इज प्रेजेंट अबव इट्स critical temperature, and if you keep this superconducting material in the magnetic field, the magnetic force lines, they will penetrate your sample material. Okay, as shown here in figure A. This is the first case. Okay, this is the feature of a superconducting material. Okay, now the second case. Now you have same superconductor material. I'm using the letter M here for superconducting material, and you are keeping this material here below its critical temperature. So hypothetically हम मान लेते हैं कि ये जो हमारा सुपर कनेक्टिंग मटेरियल है, ये जो हमारा M है यहाँ पे मेटल, इसका क्रिटिकल टेम्परेचर सपोज 10 डिग्री है। ओके, सो above 10 degree it is behaving like a simple metal, and below 10 degree it will behave like a superconductor. Okay, so now suppose this metal, it is present below 10 degrees Celsius, which is the critical temperature for this metal. So this means this metal, it is present here below its critical temperature. This means it is present in its superconducting state. And under this condition, if you keep this material in the magnetic field, in that case, the magnetic field line, they will be repelled by this material. Okay, see this figure number B here. In the center, the circle, it represents your material which is present in its superconducting state. Means you are keeping this material below its critical temperature. ठीक है, अगर आप इस सिचुएशन में इस मटेरियल को मैग्नेटिक फील्ड में रखते हो, the magnetic line, they will not penetrate your material because this material, it is present here in its superconducting state, so it will repel the magnetic field. Okay, so here you can see the arrows, they are okay, not penetrating your sample. Okay, this is also the feature of a superconducting material, and this process, this phenomena, this mechanism, it is called as Meissner effect. क्या कहते हैं इसको हम? We call it this effect as a Meissner effect. भी समझ में आ गया बात सभी को?
Yes, sir.
Okay.
Yes.
Good. Now, type 1 and type 2 superconductors. Just wait 1 minute. Okay. So earlier, what we have discussed that. Just wait 1 minute. Just wait. Okay. So, okay. in the last few slides, what we have discussed, when we keep a metal below its, or when we keep a superconducting material below its critical temperature, under that situation, it behaves like a superconductor. Okay, so now one more thing. If you place that material in some magnetic field, okay, in some applied magnetic field, so if you want that, so or you can say there is one more factor which control the superconductivity of our material. Okay. So that factor, it is critical magnetic field, that is our BC, critical magnetic field. So as we have discussed, we need temperature below the critical temperature to have superconductivity. In the same way, we need critical magnetic field. Okay, we need critical magnetic field. Okay, only below which the material it behave as a superconductor. Okay, so this condition, it is applicable when we are keeping our material in the magnetic field. Okay, so see this figure here, I'm just highlighting. So on x-axis here we have temperature, and on the y-axis here we have magnetic field, applied magnetic field here. Okay, on the y-axis, which is increasing like this way on the upward direction. Okay, so here we have two factors which are controlling the superconducting state of the material. First one is magnetic field, and second one is the temperature, that is our critical temperature. And both of these factors, they are important to have the superconducting state. Okay, so what we need, the metal, it will behave as a superconductor when it is placed below the critical temperature and below the critical magnetic field. ठीक है, अगर आपके मैग्नेटिक फील्ड, क्रिटिकल मैग्नेटिक फील्ड, दैट इज अवर BC, इससे ज्यादा है, और जो आपका टेम्परेचर है इट इज अबव द क्रिटिकल मैग्नेटिक, सॉरी, पहला पॉइंट तो हो गया कि आपका अप्लाइड मैग्नेटिक फील्ड, अगर ये आपका क्रिटिकल मैग्नेटिक फील्ड से ज्यादा है, आपका मैग्नेटिक फील्ड के समवेयर हियर, और आपका टेम्परेचर इट इज अबव द क्रिटिकल टेम्परेचर, your metal, it will behave like normal state, it will behave like normal metal. Okay, so for the superconducting state, the applied magnetic field, it should be below the critical magnetic field, यहाँ पे होना चाहिए, and for the temperature it should be below the critical temperature. So only under these conditions your metal, it will behave like a superconductor. ठीक है, मतलब कि आपका इस रेंज में होना चाहिए मैग्नेटिक फील्ड, और टेम्परेचर आपका इस रेंज में होना चाहिए, below TC and below BC. Only then your metal, it will behave like a superconductor. If you have higher values of applied magnetic field than that of BC, and higher value of temperature than that of TC, your metal, it will behave like normal metal. Okay, तो भाई ये समझ में आया थोड़ा सभी को क्या हो रहा है यहाँ पे?
Yes, sir.
इसका मतलब देखिए, इसका मतलब है यू कैन कंट्रोल द सुपर कनेक्टिविटी ऑफ मेटल just by varying the temperature and applied magnetic field. ठीक है, you can control, we can control basically. Okay, so based on this type of behavior, I told you earlier, superconductors, they are diamagnetic in nature, they repel the magnetic field. Okay. So based on that factor, we can classify superconductors into two types: type 1 superconductor and type 2 superconductors. Based on the diamagnetic behavior, diamagnetic property of superconductors, we can classify them into two types: type 1 and type 2 superconductors. Okay, so we will discuss both of them. First, we will discuss type 1 superconductor. So देखिए, diamagnetic का मतलब क्या होता है? It is magnet repelling. It is repelled by the magnet. Okay. And यहाँ पे, if you see here in this graph, see the graph here. I am highlighting here. This graph belongs to type 1 superconductors. If you see this graph clearly, on the y-axis here, on the vertical axis, we have here magnetization. Okay, this one. And on the x-axis, which is a horizontal axis here, we have here applied magnetic field. Now see this graph clearly. Let me zoom it. Okay. Okay, on x-axis, we have applied magnetic field, which is the horizontal line, and on the vertical axis, which is our y-axis here, we have magnetization. Magnetization means magnet attracting power, you can say. Okay, so if you see here, as the applied magnetic field increase here, see here, as the applied magnetic field increase here, you will have decrease in magnetization. Let me just explain. See here now, as the applied magnetic field increases here, you will have decrease in the magnetization. Okay, suppose applied magnetic field यहाँ तक है. See the yellow lines. So you will have here magnetization. So here you have decrease in magnetization. Okay, and this decrease, it goes on until you reaches the critical magnetic field here. Okay, at this point, when you reach the critical magnetic field, you have lowest magnetization. You can say you have largest or highest decrease in magnetization. Okay, so within this area, the superconductor material, it is in the superconducting state. Okay, and if you further increase the applied magnetic field here, the superconducting state immediately change into the normal metal state. Okay, means above the critical magnetic field, that is your BC here. अगर आप BC से आगे जाओगे, BC it is your critical magnetic field here. Okay, अगर आप इससे आगे जाते हो और magnetic field apply करते हो, then the superconducting state of the metal, it will be lost immediately, and your metal, it will become normal metal. So, and under this situation, if you see here, you will have this value of magnetization here. Okay, means उसमें magnetic character आ जाएगा थोड़ा सा. It will be attracted by magnet. Okay, so this thing happen in case of type 1 superconductors. Here The transition from superconducting state to normal state, it is very sharp. The superconducting state, under the influence of magnetic field, it can change sharply to normal state. ये जो transition हो रहा है ना superconducting state to normal state, it is sharp here. Okay, देखिए एक बात हमेशा याद रखिए, जो superconducting material होते हैं ना, they are diamagnetic, they are repelled by the magnet. Okay, that's why we have decrease in magnetization here in case of superconducting material. Okay, we have a decrease in magnetization. Okay. This means the metal, it is present in the superconducting state here, and this state, it is present below the BC, below this critical magnetic field. And if you further apply, increase the magnetic field above the critical magnetic field, your metal, it will immediately change into normal state, this state. And if you see this state, it has magnetization power higher compared to superconducting state. So this is the feature of a type 1 superconductor. ठीक है, अभी समझ में आ गई सभी को बात?
Yes, sir.
Okay, so this is the first case. Now type 2 superconductors. The difference between type 1 and type 2, it is very simple. In type 2 superconductors, अभी देखिए यहाँ पे क्या हो रहा है, यहाँ पे जो ट्रांजिशन है from superconducting state to normal state, it is sharp, it is immediate, no transition state formation in case of type 1. In case of type 2, the transition, the change from superconducting state to normal state, it takes place through a intermediate state, through a transition state. Okay, इसका मतलब क्या है कि टाइप 2 सुपरकंडक्टर्स में एक इंटरमीडिएट स्टेट बनता है. Okay, when we are moving from superconducting state to normal state, what we have a formation of a intermediate state, transition state, and that state, it has feature of both superconducting state and normal state. Okay, so that thing happen in case of a type 2 superconductors. Okay, so type 2 superconductors we will discuss, okay, day after tomorrow. ठीक है भाई, briefly मैंने आपको बता दिया है, okay, that we will discuss day after tomorrow, type 2 superconductor. अच्छा भी हमने फ्राइडे को अपना इंटरनल टेस्ट प्लान किया हुआ है, सभी को पता है ना भाई?
Yes, sir.
ठीक है, तो इट विल बी एक क्विज टाइप टेस्ट. ठीक है, आपका यूनिट मैंने पहले भेज दिया हुआ है, तो यू कैन रीड द दिस यूनिट केयरफुली. तो यूनिट में से ही इस जॉब को भेजा है, उसी में से मैंने क्वेश्चन पूछे हैं, और कहीं कहीं में से बीच में से उठा के जो उसका मेन क्रूशियल पॉइंट है, तो आपको एक बार अच्छे से पढ़ना है. ठीक है भाई, समझ में आ गया बात? अच्छा, अभी आपकी जल्दी से अटेंडेंस ले लेते हैं. एक और चीज याद रखनी है कि सभी के लेक्चर पूरे हों, मोर देन 75. चलिए जल्दी से अटेंडेंस ले लेते हैं आपकी सेक्शन की. टुडेज 5th. Okay, Abhinav 63. Then Aman Sharma 64. Then Ariv Ahmed 56. Then Arun Kumar 73. Then Ayush Chaudhary 71. Chad Sharma 57. Gautam 47. Kamya Jain 60, Kartik Gupta 76, Kushi 72, Kshiti 77, Lakshit 75, Varsha Reddy कितना 78 है 79? Reddy 78, Pratiman 60. Okay, Varsha. Pratiman 65, Priyanka 79, Raj Jaiswal 59, Roshan 69, Shashwat 67, Shreya 42, Swati 58, Tanishq 49, Ujjwal 43, Urvi 52, वंशिका 44. वही वंशिका, आप कल वाइवा में आए नहीं, कहाँ थे वंशिका? विधि 50, विधान 51, विपुल 41. क्लास में हो कि लंच वगैरह कर रहे हो? ओके ठीक है, अगर इसके अलावा भी कोई और बच्चा प्रेजेंट है जिसका नाम मैंने ना लिया हो क्लास में, ठीक है, यू कैन टेल मी.
राहुल.
क्या नाम है? राहुल. राहुल कंवर. उसका कितना है? राहुल 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 राहुल.
सर 68 है उसका.
अच्छा 68 है. ओके ठीक है, चलिए भी ठीक है. आई विल सी यू डे आफ्टर टुमारो. और जिस बच्चे का वाइवा रह गया उसका हम बाद में ले लेंगे कभी, ठीक है? हमारे पास नेक्स्ट वीक भी है, ठीक है? चलिए भी, आई विल स्टॉप हियर. आई विल सी यू डे आफ्टर टुमारो. स्टे सेफ, स्टे हेल्दी. ओके, बाय एवरीवन.